Welcome back to our Predictive Analytics series. Myself, Gokul. I'm working as an assistant professor in the Department of MBA, Sri Muthukumaran Institute of Technology. In this part 2 of Unit 4 Predictive Analytics and Data Mining, we will explore how to build predictive models using both logic driven and data driven approaches. Today, we will cover logic driven models, cause and effect and influence diagram, then data driven models, retail pricing markdowns, clustering time series, neural networks, then third, hard versus soft clustering. Let's begin with logic driven model. There are two main ways to build predictive models. Then first one is logic driven model based on experience, knowledge and logical relationship between variables and constants. This approach asks how do we put variable together to predict future outcomes. Second, data driven model based on statistical patterns learned from historical data. The data speaks for itself. Both approaches have their place. Sometimes we combine them using business logic to guide what pattern, what data pattern to look for. Then cause and effect diagram, fishbone diagram. The cause and effect diagram, also called as fishbone diagram because of its shape. It is a visual tool that helps hypothesize relationship between potential cause and an outcome. It was developed by Dr. Kauro Ishikawa, so it's also known as Ishikawa diagram. Categories of causes often include human factors, technology factors, policy factors, process factors. By listening potential causes in these categories, teams can establish basic relationship that impact business performance and then test them with data. Then influence diagram. Another useful diagram for conceptualizing relationship is the influence diagram. It maps the relationship between variables and constants to decide business outcome like profit. Key elements, nodes, arrows, and constants. Nodes, which represents variables or decisions. Arrows, it shows influence or dependence. Then finally, constants, they are fixed values. For example, profit is influenced by revenue and cost. Revenue is influenced by price and quantity sold. Each of those may be influenced by other factors. Influence diagram help us see the big picture before diving into the mathematical details. Now let's shift to data driven models where we let the data reveal pattern and relationships. These models don't require us to hypothesize cause effect relationship upfront. Instead, they learn from the data itself. Sampling and estimation. It generates statistical confidence interval to define limitation and boundaries on future forecast for other forecasting model. Then regression analysis, it creates a predictive equation useful for forecasting time series, forecast weed out predictive variables in the current data set that add little to prediction values. Then generate a trend line for forecasting. Then correlation analysis, access variable relationship, weed out predictive variables in forecasting model that add little to predicting values. Then finally, probability distribution, estimate trend behavior that follows certain types of probability distribution, conduct statistical test to confirm significance of variables. Then retail pricing market down model. A classic example of data driven model is the retail pricing market down model. Price markdown is when retailers deliberately reduces selling prices, often to clear inventory or respond to competition. A data driven model can analyze historical markdown and resulting sales, seasonal patterns, competitive pricing, and inventory levels. By learning from past markdown events, the model can predict optimal markdown timing and depth to maximize profit while clearing inventory. Then we will see about the clustering model. A clustering model partitions a data set into groups called clusters, where items in the same cluster are similar to each other. Each cluster is represented by centroid, the center point of that cluster. When it works, the data naturally forms distinct groups or clusters. When it doesn't work well, when data is smeared evenly distributed without natural groupings, then diagram elements, you will typically see cluster centroids, which means center points, and data points belonging to different clusters shown in different colors. Clustering is unsupervised learning. We don't pre-label the groups, we let the algorithm find them. Then hard clustering versus soft clustering. They, there are two main types of clustering: hard clustering, exclusive clustering, soft clustering, fuzzy clustering. Hard clustering means every data points belongs to only one cluster. Example, a customer can belong to either high value or low value segment, not both simple and interpretable. Soft clustering, every data point may belong to several clusters with fractional degrees of membership. Example, a customer might be 60% high value and 40% medium value. More flexible and realistic for many business scenarios. Example matrix in hard clustering, node 1 belongs to cluster 1 only. In soft clustering, node 1 belongs to cluster 1 with zero point 0.7 membership and cluster 2 with zero point 0.3 membership. Soft clustering recognize the real world entities often have mixed characteristics. Then time series model. A time series model analyzes data points collected or recorded at specific time interval. The goal is to understand underlying patterns and forecast future values. Key components of time series: trend, seasonality, cyclic pattern, noise. Trend: long term increase or decrease. Second, seasonality, regular pattern within fixed periods, monthly and quarterly. Cyclical patterns, repeating patterns with fixed periods, not tied to calendar. Noise, random variation. Examples: stock price over time, monthly sales figure, daily website traffic, quarterly GDP growth. Time series models like ARIMA, which means auto-regressive integrated moving average, are specifically designed for this type of data. Then neural network. Neural networks are computing system inspired by biological neural network like the human brain. They consist of interconnected nodes organized in layers. Input layer, which receives the data, hidden layer, process the information, then third output layer produces the prediction. Key advantages are it can model complex non-linear relationship. It learns from examples without explicit programming. Then third, adapt as new data becomes available. Neural networks are powerful for image recognition, speech processing, and complex pattern recognition. However, they often require large amount of data and computational power. And that concludes the part 2 of Unit 4. We have explored both logic driven and data driven predictive models from Fishbone diagram and influence diagram to clustering, time series, and neural network. In part 3, we will focus on specific techniques like regression analysis and classification model. Thank you for watching. If you found this video helpful means please like, share and subscribe. And if you have any questions means leave your questions in the comment. See you in the next part. Thank you.